Currently, we can utilize function overloading so that we can have multiple functions with the same name and different parameter list. This might be useful if we want to be able to use the same functionality for different data types. But in some cases, this means duplicating our code. So can we write the function once and use it with any data type? By utilizing templates, we can make a function that will handle any data type. To create a function that uses a template to be a placeholder for the variable's data type, we need to prefix the function with the template prefix. You can put anything you want in place of the t, but the t is the standard in much of the code that you will see. Secondly, you will use the t in place of the data type that would change. Note that you can still have hard-coded data types in the parameter list and as local variables in the function though. As long as the variable passed into the template has all of the needed functionality that is used within the function, it should be okay. So for this function, any data types that t represents must overload the stream operator. Then from the outside, calling the function is simple. It looks like any other function call. You can also have multiple type parameters as well, if you require different data types that are not hard-coded. Templates can also be used with classes in order to build more complex structures. For example, a class that contains a dynamic array and handles the memory management and resizing functionality internally. By making it a template, we only need one dynamic array object for any data type. Similar to with a function template, we start with the template prefix, but at the beginning of the class. Then, anywhere we use this type within the class, we use t, and we write the rest of the functionality normally. When we declare a variable using this class, we must specify the type within the less than and greater than signs. Then we simply call the functions and pass in the data type we need. But keep in mind, when you view classes using templates written by other people, you might notice that the function definitions tend to be stored with the class declaration, or all in one h or .hpp file. Different compiles may handle templates differently, but this is the safest thing to do. Include the entire class and its function definitions all in one header file. There are ways to work around this, but for the time being, implementing function definitions within the class declaration is generally good enough. Let's implement a dynamic array wrapper class and use templates. Then you won't have to implement a class that takes care of memory allocation and resizing anymore. You already have a generic class for it. Though really, I tend to use std vectors anyway. Okay, so I already have a dynamic array class created. We're just going to change it into a template. So let me minimize all of these so we can see the entire thing. We have the dynamic array. Right now it just is a list of strings. So here it's being used and we can see it working. It has a cout at every function beginning. So here we're going to say template type name t, and anytime we were using string for the list items, we're going to replace it with t. So let's start with dynamic array. The list is null, nothing we have to do there, nothing we have to do there. This is when the user's passing in a new value. Instead of passing in a string, they'll pass in something, we don't know yet. Then it will just go through, do the checks to create the list or resize the list, and then add it to the list. Display, as long as whatever the data type is for t has the stream operator overloaded, this should be fine. Get size will return element list, create new list of t items. Destroy list, so it just deletes the list, and then resize, we need a temporary list of type t. It copies everything over, destroys the old list, and then updates the pointer. So this should be okay to go. Missing argument. Oh, so now we've updated this. This needs to say it's a string array now, so that should work. And it works the same. But now we can also have an array of floats or something. Prices.insert, and so on. We can say states.display and prices.display. So it has a bunch of junk because that's the class functions, but then here's display list, it will show us everything. Down here, display the list of prices. It calls the destructor, destroy list, destructor, destroy list. This would be both of the different data types here. So I don't know what order they're being destroyed in, but one's being destroyed and then the other's being destroyed. So using templates is not too hard. You need to have the template prefix at the beginning of the class. You need to replace your data type, just the specific one, to what it's going to store or what's going to change. Change those all to T, and then otherwise, everything you can pretty much reuse the same code.